Hey, welcome back to your favorite pre-calculus class. Let's take a look at critical review 13 here. We're going to multiply divide radicals and look at the product property of square roots. If you have like the square root of 2 times the square root of 3, it'd be the square root of 2 times 3. As long as they're the same index, right? Both of these are second roots. We don't write that red 2 in there. They got to be the same root in order to do that. So here's that first one, square root of 3 times the square root of 17 would be the square root of 3 times 17. We can put them all underneath the same radical. Of course, that doesn't simplify, so we're just left with the square root of 51. Similarly here, we can put them all underneath the same radical, 5 times 11 times x times y. So we have the square root of 55 xy. Nothing simplifies. Go ahead and try that next one. Should get square root of 26 AB. Now sometimes they will simplify for you, like the square root of 31 times the square root of 31. There's two of a kind, right? We're taking the square root, which is just 31, right? Because the square root of 31 times 31 is 961. Which again is 31 squared, right? So that will simplify. Square root of 23 times square root of 23. Two of a kind is 23. So we got 23 squared under there. Let's continue on, do some more. Let's do start. If you had square root of 500, I like to break that up, right? I'd say, well, 500 is like 100 times 5, and I know 100 is 10 times 10. Again, I'm looking for two of a kind, so I have 10 root 5 as far as I can go with that. Right? Square root of 98, I'd say, well, what are factors of 98? And I would simplify 98 into, I say, well, that's 49 and 2. I know the square root of 49 is 7, or if I want to keep going, remember I'm looking for two of a kind, so I'm taking the square root. Square root of 49, that 7 comes out. So I have 7 square root of 2. Go ahead, pause the video, try that square root of 162. And you should factor that 162. You know if it's even, it goes into 2. So 81 times 2 is 162. Which of course is 9 and 9 and 2. So we got 9 root 2. 605, since it ends in a 5, if it ends in a 5 or a 0, you know it'll go into 5. So 605 divided by 5 is 121. So 121 times 5 is 605. 121 is 11 times 11. So square root of 121 is 11. So the 11 comes out. We'll keep going with that square root of 99. We've got repeated numbers there. It'll go in, so we know that's 9 and 11. And square root of 9, of course, is 3. So we got 3 root 11x underneath the radical there. All right, looking up that square root of 63x. Pause the video for this. You try problem. Should see 9 and 7. 9 times 7 is 63. We know the square root of 9 is 3. So we got 3 root 7x. 85 ends in 5, so I know 5 times 17. The problem is those are both prime numbers. I don't have two of a kind, so I'm just stuck with the square root of 85. I can't simplify any further than that. 245, that'll go into, ends in 5, so that'll go into 5. So 49 times 5. And then I've got 6 x's. X to the 6. So let me keep going with the 49 there. We got 7 and 7 and 5 and then 6 x's. So 7 comes out. Anytime I got two of a kind, so here's 2 x's, the x will come out. Here's 2 more x's, another x will come out, because again the square root of x squared is just x. And I have 3 sets of those. And what am I left with underneath? Just a 5. So this just ends up being 7x to the third root 5. Now what you'll see a lot of the time is maybe you want to think about it this way. I've got x to the third being squared. I have 2 sets of x to the third. So I've got a 7 coming out, I've got an x to the third coming out, and I'm just left with the 5 underneath. You could do it that way too. However you want to think about that, but you can go ahead and pause the video on this next one and try it. Well, you got 3x 9 times 7. You got 8 of these x's, so there's 2 sets of x to the 4. Square root of 9, we got 3 times 3, and then I've got x to the 4th coming out, so I'm left with just a 7. So 3x to the 4th, square root of 7 on that. Now notice this x to the 15th, we've got an odd amount of those, right? So I'm going to think about that, and again, you can always write out 15x's if you really want to, but I think that's pretty tedious. But I'm going to think about that as, let me take out 14 and 1x. So there's my 15x's. And then I can write that x to the 14th is x to the what quantity squared? Well, I know 7 x to the 7th squared is 14. Right, so I've got 2 sets of x to the 7th. So an x to the 7th comes out, and I'm just left with x underneath. And again, you could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Probably don't want to do this, but you could. 1 comes out. 2 comes out, 3, 4, 5, 6, 7, and you're left with the 1 underneath. So again, x to the 7th root x. However you want to think about that. Why don't you guys try that x to the 21st. Go ahead and check your work on that square root x to the 21st. You get that x to the 10th root x. Let's move on to the next one. We know 99 is 9 times 11, and 9 is 3 times 3. And then x to the 17th, I'm going to write that as x to the 16th with an x. 3 comes out. And x to the 16th, I'm going to write as x to the 8th squared. So I know an x to the 8th comes out. So 3x to the 8th, I'm left with an 11x underneath my radical there. Go ahead and try those next couple. Check your work on that. Square root of 75, x to the 13th. And then I'm looking at the 490 and I'm thinking to myself, well, 490, that's going to go into 10, right? 49 and 10. And then y to the 15th. So I'm going to write that as y to the 14th y. So I got square root of 49 is 7. Can't do anything with 10, but I'm going to write the y to the 14th as y 7th squared, so the y to the 7th comes out, and I'm left with square root of 10y. So 7y to the 7th square root of 10y. So we end up with that 5b to the 4th square root of 14b. Let's move on here. Now here, I'm not going to multiply 55. I can put these all into they're the same index. They're both square roots. So I'm just going to multiply 55x squared times 5x. And then I can multiply 55 and 5. Now I'm not going to put them together because I know 55 is 11 times 5. And I have that other 5 from the 5x. And then I've got x squared and I've got x. So I'm like, oh, square root of 25 is 5, right? Square root of x squared is x. And what am I left with underneath? Just an 11x. Similarly for this, you try it if you want to pause it. Should get that 7x root 5x on that you try it problem. Let's keep going with a little bit more variety here. We got square root of 98 x y. So I got 98, which I know is 49 and 2 xy. I've got 4, which I know is 2 and 2 xy squared. So I got 49, I got 2, 2 more 2's, and then I got an x, an x, I got 2 x's, I got 3 y's. Just write them all out. So square root of 49, 7 comes out, square root of 4, 2 comes out, square root of x squared is just an x, square root of y squared is just a y. Looks like I just got a 2y underneath, so I got 14xy square root of 2y on that. Alright, so there's that you try problem. Should get 6xy square root of 3y on that. Well, that brings us to the quotient property of square root. So if we have square root of a over b, we can go, that means that's the square root of a over the square root of b, as long as b is not 0. Right? So that square root of 132 over 3, notice they're separated right now, so I could go the other way. Since they're both square roots, I could put them all together, hoping that they do simplify, which they do. That's the square root of 44. And then we know 44, 132 over 3 is 44. We know 44 is 4 times 11. We know the square root of 4 is 2. You go ahead and try that next one. You should get 4 root 2 on that you try problem there. Next one we got, both are square roots. Let's go ahead and put them all underneath the same radical. So I've got 168 divided by 6 gives us 28. I got 10 x's on the top, 1 on the bottom, so I'm just left with 9, right? 10 minus 1. I'm left with 9 here, so I'm just taking care of this square root of 28, x to the 9. Well, 28 is 4 times 7. 4 is 2 and 2. And we've got x to the 4th squared is x to the 8th. So it looks like I have a 2 coming out. I have an x to the 4th coming out. And I'm just left with a 7x underneath. So 2x to the 4th square root of 7x. Check the work on that. 3x squared, square root of 5x. Pause that if you need to. Alright, let's get into some other higher roots. Here we've got, and those same properties apply for the nth root as they did for the square root. Let's look at a third root of 189. So the third root, if you have a third, the third root of a equals b if and only if a equals b cubed. So I'm just looking for 3 of a kind when I'm doing a third root, right? So I got to factor 189, and so I'm thinking to myself, well, what goes into 189? How about 27 and 7 go into 189? And I'm going to keep going with my 27. 27 I know is 9 and 3, but 9 is 3 and 3. So 3 times 3 times 3 times 7 are all my prime factors of 189. Again, I'm looking for 3 of a kind, right? Not 2 of a kind. So I'm looking for a third root. The third root of 27 is 3. So if 3 comes out, and I'm just left with 3 times the third root of 7 as my solution on that one. Let's do another one, 320. And this ends in, again, if it ends in a 0 or 5, you know it's going to go into 5 at least. So I'm going to go, I think 64 times 5 will give you 320. And I know 64, oops, 64 is 8 and 8. Eight is 2 times 2 times 2. Again, I'm looking for 3 of a kind. So a 2 will come out. Another 2 will come out. And I'm just left with the third root of 5 underneath. And I go ahead and multiply the red and the green 2 there. So if I got 4 times the third root of 5. So in all actuality, the third root of 64 is 4. Right? If I had noticed that right there, the 64 is 4 times 4 times 4, I could have just done it right there instead of factored it all the way to a bunch of 2's. Let's go ahead and try the third root of 162. and the fourth root of 405. Check that you try. I should get 3 times the third root of 6 there. Let's try the fourth root of 405. So this time we're looking for 4 of a kind, right? If the fourth root of a equals b, if and only if a equals b to the fourth, right? And so the fourth root, I'm looking for 4 of a kind. I'm going to break up 405. Again, if it ends in 0, 5, I know 5 is a factor of it. So 405 divided by 5 gives you 81. So I got 81 and 5. And I know my 81 is 9 times 9. And I know those 9s are going to 3s. I'm like, hey, I got lucky. I got 4 of a kind there. So 3 comes out, and I'm left with the fourth root, and I just have a 5 underneath there. Let me try that next one, fourth root of 243. I should have 243 factors into 9 and 27. 9 is 9. 27 is, I'm sorry, the 9 is 3. 27 is 3 times 3 times 3. So you got 5 3s underneath there. So 1 will come out with a set of 4 there with 1 left underneath. Let's do some fourth roots here. I got fourth root of 25, 125. Notice they're both fourth roots, so I can put them all underneath the same radical sign there. So I got 25 is 5 and 5. 125 is 5 and 5 and 5 is the 125. Again, I'm looking for 4 of a kind. So 5 comes out, and I'm just left with 1, 5 underneath that fourth root there. Go ahead and pause it. Try that next one. Check yourself on that blue one there, and then we'll get into third root of 11 over 125. Now, we can't simplify that at all, so we're just going to go ahead and split this up. So I have third root of 11 on the top. I have the third root of 125 on the bottom. 11's already prime. There's nothing I can do with that. The 125 I do know is 5 times 5 times 5. So the third root of 125 is just a 5 on the bottom. So I have third root of 11 all over 5. Similarly for that U-try problem, if you want to check that, you should end up with fourth root of 7 all over 2 on that. So much for taking notes, and see you next time.